cook uses a fire tongue of length 28 centimeter and to lift a piece of burning coal of mass 250 gram. If he applies the effort at the distance of 7 centimeter from the fulcrum, find the effort. You can take G as 10 meter per second square. So first is a figure required here. So this is a fire tongue. Okay, so draw a fire tongue here. And this is the coal or whatever that he is lifting here. Okay, this is the fulcrum. Fine. And here tongue length is 28 cent. Total length is 28 centimeter. 28 centimeter total length from the fulcrum to the final length. And coal is how many grams? This is 250 gram. So 250 gram here. He uses a tongue of 28 to lift this much of 250 gram of coal. If he applies an effort at its distance 7 centimeter, he applies and ups here. This is the effort. How much? At a distance of 7 centimeter. 7 centimeter. From the fulcrum, find the effort. Then we have to find the effort in it. Okay. So see, we will use the formula of moment of force. Equilibrium in the moment of force is what? Load arm. Right, load into load arm. Right. Is equal to effort into effort arm. Okay. This is the principle of equilibrium. Now, first of all, we have to convert, this is gram, we have to convert that into what? Kg, and then multiply with G, kilogram, and then multiply with gravity to get the force in it, that is the weight of it. So we know that weight of this particular coal piece is what? Weight is a force, and that is equal to how much? Mass into gravity. Mass is how much? 250 gram. I have to convert that into kg, so divide by 1000, right? And into 10. 10 is this one. So we know that these two will get cancelled. You get what? 2.5 kg, right? 2.5 Newton. So force of the weight of this particular coal is how much? 2.5 Newton. This is what it was lifted. Fine. And so how much of force that he needs to apply? So load is how much? 2.5 Newton into load arm is how much? They have given. We can subtract that. Total is 28 centimeter, right? So I will subtract from there what? Subtract 7 centimeter. How much is that? 21 centimeter. So this is the length here. Length is, come on. Something wrong. Something is wrong here. Okay, there was some connection issue in it. We lost whatever we wrote here. Anyhow, so this is how much? 28 centimeter total, and this length is 7 centimeter. Okay. Load is, effort is applied 7 centimeter. Okay. Oh, there was no need to subtract it. I'm sorry here, because this is the fulcrum. We have to get the distance from the fulcrum here. So load is load is equal to 250, we convert that into grams to kilogram and multiply by 10 to get the weight. That will give you how much? 2.5 Newton. Now after that we will have to find the load arm. Load arm, right? So what is the load arm in it? Load arm length is, where is the load? Load is here. From this one is 28 centimeter. You can keep it in centimeter, you can convert a meter, no issue with that. And then effort, what is the effort in it? Effort is, what is the effort that has to be applied is a question mark, right? Find the effort. So let it be E. Effort is E. And effort arm is how much? 7 centimeter they have given you. Remember, both the units should be same. Okay. Now then we know the principle of moment, so that it is at equilibrium. What is that? Load into load arm is equal to effort into effort arm. Fine. So what is the load? Load is 2.5 Newton into load arm is how much? 28 is equal to effort. We do not know, effort arm is 7 centimeter. So if you find effort, effort will be equal to 2.5 into 28 upon 7. 7 4s are 28. So 2.5 into 1, 2.5 into 4 is 10. So we get finally what? Effort is 2.5 into 4, 10. So effort is 10 Newton. That okay? How much of effort has to be put? 10 Newton to lift that load, and this is the answer in it. Okay.